that are part of Python. And one is kind of a submodule of the other. And these modules are OS and os.path. If we go to python.org, which is the home page of Python, and hover over documentation, we can jump to the Python docs. And under Python docs, you will see a link for library reference. This is the portal to all knowledge about whatever comes with Python out of the box. Basically, it's the standard library, which includes the built-in functions, a handful of built-in constants, all of the built-in types such as int, string, dictionary, and so forth, the built-in exceptions, and then a couple of hundred modules that are part of Python. Basically, it's the standard library, and one of them is OS, which is miscellaneous operating system interfaces. And so there's all sorts of useful things in here. A lot of the stuff in here, I forget it's there or I just don't need, but there's a lot of really interesting things in here if you're doing a lot of admin kind of scripts. For instance, this is where you can get change dir, get the current directory, and so forth. Some of these are really handy. Access lets you determine whether the person running the script has read or write and or execute permission for a given path. Change dir does what you think it does. Change mod does what you think it does. Change own does what you think it does if you know any Unix admin. However, you probably have to be root to enjoy it. Get CWD, very important. It tells you where you are in the file system. Listdir, also very handy. Listdir will return a regular Python list of strings containing the name of all entries in a specified folder. So if you want to say, what's in this folder, this is the easiest way to get that. If you're on Windows, list drives will list all of your lettered drives. Make dir does what you think. It will create a directory, but if any component already exists, it'll raise an error. So I usually use make dirs. Make dirs lets you specify a directory with as many components, as many subdirectories as you want, and anything that doesn't exist is created, and if it's already there, it's fine. So if I say make dirs foo/bar/blah, even if foo already existed, it'll create bar and blah, so it's very handy. OS remove is your all-purpose X-Acto knife. OS remove will remove a folder. I'm sorry, not remove a folder. It will remove any file. Rename allows you to rename a file or folder to a new name. rmdir will let you remove an empty folder. Let's see, anything else? Those are the most important ones. There's a few others. For process management, you can call OS exit, but you can also just type exit without the prefix, just exit with parens. to exit your program. If you need to kill a process, you can use os.kill and the process ID. A lot of these are pretty advanced or special purpose. OS system can be used to run an external program. Do any of you use OS system?
No.
Good. If you need to run external programs, you should use the subprocess module, which is part of that efficient programming chapter, or efficient scripts, effective scripts chapter. Do any of you use subprocess?
I do. A lot.
Excellent. Okay, those are the main ones in OS. Just want to make sure everyone was familiar with those. And oops, in a different area is os.path. os.path I use a lot because it has all of these really useful functions. abspath gives you the absolute path to a folder relative to where you, I mean, you can specify the folder relative to where you are, but it gives you the absolute path. Base name gives you um, just the name without all of the leading folder information. Dir name is the other part, everything but the last component. Exists returns true if a file or folder exists. I'll show in a minute an example, but these get X time return the access time, the modification time, and depending on your operating system is either the last metadata change or the creation time. Get size lets you get the size of a file in bytes. Then there's a bunch of is whatever functions. Is absolute path, is file, is dir, is link, is mount point, which you don't really care about. os.path.join, real handy for joining one or two or more path components, that is folders, together. On Windows, which you are, split drive will split into the drive letter and everything else of a path. And split root gives you the drive letter, the root, and then everything else. And everything else can be further split with dir name and base name. And split ext or split extension splits into everything but the extension and the extension. So if we split foo.bar.exe, it splits into foo.bar and .exe. It basically splits off the last thing in the path name that starts with dot. But all of these can be handy for general admin scripts. Everybody's good with that?
Yep. All good here.
Yep. So we're more or less on page 31, and what I'll do now is give you a little demo of some of these things we can do. So first off, in the data folder is a file called alice.txt, and it's basically the text of Alice in Wonderland, or what we think of as Alice in Wonderland. technically it's Alice's Adventures in Wonderland. But that's a file. So I'm going to say folder equals data and file name equals alice.txt. So, and I'm going to import OS, which automatically lets me use os.path. So with this information, now I can do some fun stuff. I can say file path equals os.path.join folder and file name. And now on Windows, this will put a backslash between the components, but on Mac or Linux, it will put a forward slash. So there's my file path. If you try this at home, you'll see it puts a backslash on Windows. So now that I have my path to the file, I can apply some other functions to it. I could say file size equals os.path.getSize on the file path. And we'll see that file is about 148 or so thousand bytes. I can say
Thinking of the forward slash and backslash, why you would want to use os.join as opposed to just putting in as a string data slash alice.txt.
well,
So that way you can determine based off of your OS which one it is.
you could do this, or even all of those would do the same thing. However, on Windows, in both cases, if you wanted a literal backslash, you would have to double it up like that, same here, to make it actually come out as a single backslash, and it's a little ugly. And in fact, on all platforms, including Windows, when you have a literal file, you can just use a forward slash, and Python will figure out if you have a file name in literal quotes, you can use a forward slash everywhere. The advantage of using OS path is OS path picks the right slash for your operating system, and it keeps you from making mistakes doing things like this. And I won't say it's less typing because you have to type os.path.join, but it also, I argue that it indicates what you're really doing. Your os.path.join means I'm creating a new path. So I prefer line 8, but there is nothing incorrect, so to speak, about line 6 or line 7. And I'm not sure I've actually answered your question. I've given you more info.
No, I mean, that's good. Usually what I end up doing is, and I'm sure this isn't the best practice, is I just use like a string and it's just data slash alice.txt.
Oh, well, if you already know both, sure, I could just do file path equals, yeah, os.path.join is handy when your folder and your file happen to come in different places, when you're not hard coding them, because things like file names, we talked a little bit before class started about learning best practices. Best practice is not to put things like file names in your actual scripts.
Okay.
Best practice is to leave them external and pass them in either as command line parameters or interactively using input, or read them from a file, typically some kind of config file, or get them from the environment.
Gotcha. Okay.
But if you know that you're just going to pass in the path to the file, absolutely just pass it in as data/alice.txt or hard code it. What I'm showing here is sometimes it's convenient, and there's an example coming up that'll make this more clear. For this particular case, lines 6, 7, 8, 9 pretty much do the same thing, so any of them is fine. They will all work. But sometimes you have your file folder, and then maybe you have a list of names to open in that folder, and that's one place where os.path.join is good, because we know it always does the right thing.
Okay, yeah, that would make sense.
So we could use getImpTime to get the raw timestamp. That is the time and date at which this file was last modified. Now, in the next chapter, we'll talk about dates and times, but this happens to be returned as what we call a Unix time or a Unix epoch time, and it's the number of seconds and microseconds since January 1st, 1970. Of course, that's number is not very useful to us human beings, so I'm also going to say from date time import date time, and then I can say file timestamp equals date time dot from timestamp raw timestamp. So it turns out that this file was last modified on February 3rd of this year. Probably the last time I generated this course from my Course-O-Matic system. So we'll take several breaks this afternoon because we have a long afternoon since we did lunch a little early. We still have 4 more hours, just so you know. And tomorrow will be a little better on that. I better make a big note to myself to start at 9, so I'm here. Otherwise, Travero will be hounding me down. Anyway, so here is a bunch of nice tools you can use from os.path. I can also say now in this case I already have the directory separate, but in other cases you might be past a path and you want to get just certain parts of it. Since I'm going to use the absolute path a bunch of times, I'm going to change this up a little bit. Now I probably should write this out in advance, but there's the absolute path, which which is an advanced Python, which is on my desktop. So the base name is just alice.txt. The dir name is everything except alice.txt. Split splits it into the base name or the dir name and the base name. Split X splits into everything but the extension and the extension. So all tools you can use to manipulate your paths. So, any questions on using OS paths? Super handy for writing handy admin scripts. I guess that was from the Department of Redundancy Department. Handy for writing handy scripts.
Any questions on it? I don't know if anybody else does.
Cool. Have any of you ever used os.walk?
OS.
No, I have not.
Okay.
Never.
os.walk is very cool in my opinion. What os.walk does is allow you to visit a folder and all of its subfolders, find files that match some kind of criterion, and do something with them. It is like the find command in Linux or Mac. It allows you to programmatically scan a folder and all of its subfolders recursively and do something. Anybody have a need for that kind of thing?
I have before, but I think I have a workaround for it now. So maybe this might be better than what I'm currently doing.
What are you currently doing?
It's pulling all the database files for the SQL stuff that I'm doing, and they're in a couple different folders. So instead of doing it the way
All right, let me just show you what we might do. We'll start in the current folder, but we could make it anything we wanted. We'll do it that way. So os.walk starts at a specified folder, and it visits that folder, and then it goes to all subfolders of that folder, and then all subfolders of those folders, and so forth. So the first thing I'm going to do is just print out the current folder, so you can see how that works. Actually, I'm just going to print it. So this is going to start at current folder, which is the top level of our student files. So it's going to go to advanced Python, start there. Then it's going to go to examples, logs, setups, and temp. It will also pick up some other ones that are, I'm going to say, if not, current folder dot starts with I'll do a hack to skip the git files. There we go. So now it's only printing out all folders that do not start with ./.get. I'm going to show you a better way to avoid a particular folder or folders in a minute. But now it's finding all the folders in our student files. Now the better way to skip .git, does everybody know what Git is? I hope you do.
Yeah.
Git is the source code control tool. And when you have a Git repository, Git automatically creates a folder named .git that has a lot of stuff under it. And normally when you're doing this kind of search, you want to skip it. Well, what happens is once you hit the starting folder, then OS Walk goes to all the folders and subfolders. So to skip a folder, we just remove it from subfolders. So I can say just if Git is in subfolders, subfolders.remove Git. Now I don't have to do that check. I'm just skipping Git for the duration. Now that I'm looping over on my folders and I'm skipping Git, maybe I want to find all Python files. So how can I do that? I can say for file name in file names, guess I'm going to be consistent. Part of best practice is to keep your variable names consistent. So for file name and file names, if file name ends with .py, for now I'm just going to print so now I'm printing all the folder names, and if there is a Python file in the folder, I'm also printing that. I don't really need to print the folder names, but just so you can see what's going on, that is searching all the folders. And maybe I want to be a little more selective and say, and file name starts with C. Maybe I'll skip printing the current folder. So now I'm just finding all the files that start with C and end in .py, starting in the current folder. Now that I have the folder and the file name, I can say file path equals os.path.join current folder file name. So now I've got my file path. And then I can say something like file size equals os.path.get get size file path. And maybe I'll do this. Since I'm not printing the folder, I don't have to indent. So now I am walking through my data and finding each file that ends in .py and starts with C, calculating the size and outputting the size and the name.
What is the 8D that you put in there? Does that format the size?
It does. If I left off the 8, the D says format file size as a decimal number.
Okay.
But without the 8, it just formats it as wide as it needs to be for that number. With the 8, it says format it in a field 8 characters wide.
Okay, gotcha.
Or I could even pad with zeros, which in this particular case is not particularly helpful in readability. this is the exact size of the file in bytes. A file can't have a fraction of a byte. Sure, this is bytes. Now, they're not in the standard library, but there are a couple of modules to give you human units, and you could express the file sizes in human units like kilobytes, gigabytes, megabytes, terabytes, etc. But it's not built into the standard library. And for these files, not as important. Well, we can do one more fun thing. If you put a comma there, it will commify all of your numbers. And we can get, go ahead.
Integers, you can do that.
Say that again.
Anytime you're working with integers, you can do that formatting.
Absolutely. If I say big num equals
Okay, awesome. I had no idea. That's cool.
I didn't put in a size because I'm not putting out multiple things, but I could also have put in a, oop, sorry. As you can see, that will pad it out to 20 characters and put in commas.
Okay.
One
So those
more.
are called,
Go ahead.
I'm sorry, those are called format specifiers. So if I want to look for any others, that's what I'd be looking for.
Sure. After whatever expression you're printing in an F string, you can put a colon and format codes or format specifiers, and there's all sorts of interesting ones. You can left justify, right justify, pad. I have a whole, not in this course, but I have a whole appendix that I put into some courses that have all the gory details. One more thing we can do that you might not know, if I want to say big num equals, and I want it to be more readable as a literal number, and you can actually, weirdly enough, put underscores anywhere in a literal number and they'll be ignored. You can just put them in to make it more readable.
Hmm.
Now, I don't work with literal large numbers very much, so I don't really need to do this, but it's kind of a fun little quirk of Python that you can, because again, Python is all about readability. So these are two separate things. One thing is that in a literal integer, you can put in underscores for readability. And the second thing is in an F string, when you're displaying an integer or a float, you can use the size comma D or size comma F for a float to put in commas automatically. I said num equals, what did I do? I swear I could use a comma with F. Apparently I can't use commas and decimal points at the same time. My mistake.
I can't think of a practical reason to use this, well, like off of the stuff that I'm currently doing, but that's interesting to know that that's an option.
Yeah,
If
the F string formatting is really very powerful. All right, well, again, I don't want to spend too much time on that since it's of limited use. I'm more interested in having you admire walking directory trees. So at this point, once you have the file path, you could open the file and read it and search inside the file. You could delete the file. You could relocate it to a different folder, or you could add it to a zip file programmatically and then delete it. There's really no end to what you could do with the file once you found the file you want. And we could also say, you know, we could get the size and only say if file size less than 2000, continue. So now we're only going to find files that are at least 2000 bytes. So this is a great pattern for finding files that meet some criteria, starting at a given folder, fine-tuning what you want, and then doing something with the files or folders you find. Sure, what you could do is do this, but put the file names and the sizes in a list. And then you could sort the list by the size, and that would give you your biggest files to get rid of. I could show you that. Let me print that out in a little more readable way. So there they are, sorted by size. And now I can do something like top 3 equals sorted file sizes sub colon 3 for file size file name in top 3 print deleting. I'm not going to actually do it, but then I could grab the top 3 by using a slice, and those are the top 3 biggest files. could find me going back up here, and that's card deck, Flash, simple, whatever, and Python module. And there we are, card deck, Flash, simple, and Python module. So that's how we could delete the 3 biggest files under the current folder. 3 biggest Python files. And did that make sense? I did it a little fast. We can build anything with code. All right, on page 38, the short version is this. Now you might have to use something different to set the environment in Windows, but in Mac or Linux, I can say, I don't know, language equals Python. I'm going to say export language equals Python. Now I've got an environment variable language. If I look at set, we'll see that language is in there somewhere at the bottom, I think. I have a lot of crap in my environment, by the way, as you can see, so never mind. There we go, language equals Python. Or in Windows, you would say set language. Is it that? I forget. Something like that in Windows. Now that I've set that, I can say import os.path.getEnv language. Whoop. How about os.getEnv language? I got too enthusiastic there. So, point here is that if you need to retrieve a value from your environment variables, which is a good way to provide passwords and other sensitive or changing configuration information, if you need to retrieve a value from environment variables, you can use os.getEnv and the name of the variable. Like dictionary keys, like with dictionary.get, it works the same way. If the key isn't found, it returns none, or I can provide I don't know. So if language was not defined in the environment, this would have returned COBOL. Still my favorite language. I'm kidding, in case anybody was rolling your eyes.
Way it automatically set it in Windows is just like you set a dictionary down.
You're fading a little bit in and out. You're a little hard to hear. Can you either get closer to the mic or something?
Yeah, hang on. I switched my computer.
Okay. Now you sound good.
Yeah, let me
There we go. The headset starts to give me a headache after a little bit, so I switched off of them. The way that I always set the way that I've been setting the environmental variables on Windows with the script that I do is just like you do any dictionary. So, but it's os.environ.
Right.
And then
Go ahead.
yeah, and then like for instance, mine is app underscore username equals whatever.
Sure. You can just say os.environ sub, I don't know, city equals Durham.
Yeah, exactly. That's the way that I've been
And
doing
that
it.
will set it, and you can use that to get it too. I could say, oops. But get env has the advantage of, like dictionary get won't fail if the variable isn't there, and lets you make a default value.
Okay, gotcha.
So there might be a reason to want to use the get env as opposed to just setting it
Okay,
with the
no,
square
that makes
bracket.
sense. And one question: if you set an environmental variable using a sub process, as soon as that sub process done, does the environmental variable go away?
In Mac and Linux, for sure. In Windows, I'm not 100% certain.
Okay.
Maybe I'll try it. I have a virtual Windows instance on my machine here. Maybe I can try that. I'm gonna make a note real quick. Current class, July 28th, extra topics. Set Windows environment variable in child proc. That'll remind me enough. Okay. Alrighty, on page 40, it talks about launching external programs, but you don't really want to do it the way it says in chapter 2. That's the old way, not as good. We're going to use subprocess in chapter 10, I think it is. So don't worry about that. So on page 42, we have some more exercises. The first one is going to require you to look at the environment and look at the path variable. The path variable should contain one or more components of paths on your system that contain executable files. And your mission is to count how many files, don't worry about whether they're executable, count how many files are in each path. What I didn't show you, I talked about it, but I didn't demonstrate, so I'll do that real quick. So I'm in the top level of the student files here, just so you know where I am. I can say os.listdir data, and it returns a list of all the files in the data folder, or os.listdir answers returns a list of all the files in the answers folder. So what you can do is you'll have to use getEnv or one of the variations we just talked about to get the value of path. And then for each one of those paths, you can use listdir to get the number of files it contains. Don't worry about checking to see that it's only files. If you just use listdir and get the length of the list returned by listdir, that'll be fine. We only have so much time. And the second exercise is to find the oldest file in a folder. And for this, you don't have to do any fancy translating, but you do need to use that os.path.getMtime to get the time of last modification, and then compare them somehow. I recommend putting the file name and the timestamp in a tuple in a list, and then sorting as I did before, and then you can find out what the oldest one is. And exercise 2.3 is very similar to what I did earlier, except it's kind of combining it with exercise 2.2. That one's not as exciting, but I think 2.1 and 2.2 will be fun and tie together some of the stuff we're talking about. So chapter 2 exercises on page 42, and let's restart at 2:15. Central Time, naturally. I don't know what CET is, but I meant Central Time.
Well, we'll just say it's a mixture of CST and CVT.
Fair enough. And I also got my timer working, so you should see the timer in somewhere in what I'm sharing. Where is the timer in what you see?
Oh, yep. Up there in the top right hand corner, I see 28, 43, 42,
Sure.
41.
There you go. That's the lab timer. When that's down to 0, it'll be time to restart.
Awesome.